Hello and welcome to lecture number 2 of this series. Today we will be learning about the different primitive data types. We will learn about the difference between primitive and non-primitive data type, and we will also learn about typecasting. So let's start today's session. This slide is basically the revision of what we had discussed in the last lecture. So I hope all of you have gone through it. This is very important for your examination, for your boards examination and class 9 examination also. You need to remember all the data types, their sizes and their ranges. The data type along with their size and their ranges. This is very important. All right. So let's move on to the first slide of today's lecture. So as we have already seen in the last lecture, the primitive data types are generally of three types. We can classify it into three types: number, then comes what? Boolean, which can be a true or false, and then comes characters, isn't it? So these are the generally three different types of primitive data types. If we want, we can classify numbers into further two types: the integer type and the floating point type. So what is the difference between integer type and floating point type? Integer types can only contain whole numbers. Integer types can only contain whole numbers. Suppose we can put the number 450 into it, or we can put a number 1200 into it, or we can put a number minus 120 in it, but we cannot put a number 1.2 within it. This is wrong. All right, integer numbers can only contain whole numbers. That means it can only contain numbers which does not have a decimal point in it. Whereas floating point numbers or floating point types can contain numbers which has a decimal point in it, Suppose it can contain the number 4.56. It can hold the value 12.3. It can hold the value minus 1.4. There will be no problem. Alright. So integer number can only contain whole numbers, and floating point numbers can contain the numbers which has a decimal point in it, or it can contain decimal numbers. So integer data types are generally of four types: byte, short, int and long, and floating point types are generally of two types: float and double. What are the difference between all of them? We will discuss about each of them in the next few minutes. So let's move on to byte data type. Byte data type, what is the size of byte data type? The size of byte data type is only 1 byte. Size is only 1 byte, and it can contain numbers from the range minus 128 to 127. If you want to put a number, suppose minus 130, no, it cannot hold the number minus 130 into it. It cannot hold the number only 130 into it. Why? Because these two numbers are beyond this range. That means you cannot put a number less than minus 128, and you cannot put a number greater than 127 into it. You can only put numbers between these two. All right, so you need to remember the range. You can put a number 100 into it, you can put a number 90 into it, but you cannot put a number less than minus 128 and greater than 127. What will happen if we put a number less than minus 128 and greater than 127? Let's try it on the window. Okay, so this is our second class. Let's name it class second. All right, so let's write the code over here, remove all of those, no need now. Public static void main string args. Okay, so let's make our first variable of today's class byte a equal to 100. All right, so this is within the range minus 128 to 127, so no error. Let's try to make a second variable byte b equal to minus 130. See, an error. What? It cannot store a value less than minus 128, isn't it? Let's try to make another variable byte b equal to 130. See, again an error. Why? Because it cannot hold a value greater than 127. So you must remember it can only hold values within the range minus 128 to 127. Now if I make it 127, what will happen? There will be no error. And I'm making this minus 128. Alright. So let's try to print these three variables: system.out.print ln a. Let's copy it and print system.out.println B and system.out.println C. Let's compile it and try to run this. See, what are the outputs? 100 minus 128 and 127. 100 minus 128 and 127. All right. So let's move on to the next data type then. Our next data type is short data type. You need to remember the size of short data type. What is the size of short data type? Size is 2 bytes. Okay, I missed a point. If you think that why we will use byte, if byte also stores whole numbers and int data type also stores whole numbers, what's the point of using byte instead of int? Can anyone guess the answer? Because byte helps us to save memory. How? How byte helps us to save memory? See, int data type, the size is 4 bytes, whereas byte, the size of byte is only 1 byte. So what will happen? If you use a byte variable in your program, it will occupy less memory or less space in your device. So if you want to save memory, then you must use byte data type. It will help in making your system run faster. Alright, so we use byte data type if we want to save memory or if you only want values between minus 128 to 127. And let's move on to the short data type. So short data type is also used when we don't require int values. When we want to save memory, we can use short values. You must remember that it can only contain values from minus 32768 to 32767. It cannot contain a value less than this and it cannot contain a value greater than this. All right, I don't think I need to show that in the window anymore. It is clear with the byte data type only. So just remember, the size of short is only 2 bytes and it can contain numbers within this range. Let's move on to identity type. What is the size of identity type? I have told just now the size of identity type is 4 bytes. Size of identity type is 4 bytes and it can contain numbers from this range to this range. This is the lower limit and this is the upper limit. All right. So int is very popular. Like most of us use int in our programs. Int variables are the most common. So I don't think I need to dive deep into it much. Remember the size of int is 4 bytes and it can only contain whole numbers. It can only contain whole numbers. It cannot contain a number with a decimal point in it. All right. And the last data type within integers are long. What happens in long? Why is it special? Because the size of long data type is 8 bytes. It is the largest among all the other data types. The largest among all of them is long. The size is 8 bytes. Alright, it can contain huge numbers from minus this range to this range. Alright, so if you want huge numbers or huge values in your program, then you can use long variable. And one thing, the long values, if you are declaring a long variable, the value must end with a capital L. Why? Because that is the naming convention used in Java. If you are declaring long variables and if you are storing a value into it, you must write L at the end of it. Let's try it once. Let's try it once. Let's declare a long variable, long variable equal to suppose 150000 something L. Maybe this could have been fitting into integer data type also, but just for the sake of showing an example, I am putting it into a long variable. So this var is a variable with long data type, and this what happens? This is a space in a memory. This is a space in a memory with the name var. And what data type is assigned to it? Long data type is assigned to it, and it is containing the value 15000, this one. So let's try to print it now. System.out.println var. All right, compile it and run it. Check, it is getting printed over here. At first a 100, then minus 128, then 127, then the long value is getting printed. The var variable over here is getting printed. So var is a space in a memory which is assigned to long data type, and this 1500, this value is stored in that memory location. All right. So these are the data types within integer types. What? Byte, short, int, and long. Now let's move on to floating point types. What are the floating point types? Floating point types. Floating point types are float and double. Floating point types are float and double. Now what happens? You already know that it contains numbers with decimal points. 4.56, it will store 4.56. If you put 130.223, it will store 130.223. But as we have already seen long, if we are declaring a data type float and we are assigning a value to it, then you must write the f letter at the end of the value. If you are declaring a variable with double data type, then you must write the d letter at the end of the value. All right, let's try to store to float and double variables and try to print them. Okay, let's use this example only. Float, float variable 1, variable f stands for float. All right, 5.809 something, and then an f. Let's try to use double also. Double variable d stands for double, 19.9987, and let's put d onto it, and at the end let's try to print those variables. Let's try to print those variables. Var f and var d. Compile it and then run it. Let's check the output. See, the decimal values are getting printed over here. At first 100, then minus 128, then 127, then this 15 something. This stands for the long variable, the long data type. Then weird f. This is printing the value 5.809. See that f and d, those values are not, those letters are not getting printed. Those only signify that this 5.809 f, this value is getting stored into a variable which is assigned float data type to it. Alright, so f stands for float and d stands for double. So this is how we are printing the decimal numbers. Let's move on to the slide. And what is the difference between float and double? If anyone asks you what is the difference between float and double, what? First difference is the size. Float is 4 bytes and double is 8 bytes. Let's check. Float is 4 bytes and double is 8 bytes. So float size is 4 bytes, double is 8 bytes. Moving on to some extra points. Why we will use or what we will use? We will use float or double. As we have already seen, both of them are capable of storing decimal numbers. Both of them can store decimal numbers. So why we will use float and why we will use double? Or which one would you prefer? Okay, so I've already discussed or I've already given a hint here. The size of float is 4 byte and the size of double is 8 bytes. So if you want numbers with what? If you want numbers with greater precision, what does precision mean? If you want numbers which have huge number of values after the decimal point, suppose 6, 7, 8, 9, 2, 3, 1, 2, and it continues. If you want numbers with high precision, then you will use double. And if you want numbers with low precision, suppose 23.45, then you will use float. Why? Because float can only contain 6 to 7 decimal digits. Float can only contain 6 to 7 decimal digits, whereas double can contain 15 decimal digits. So it is safer to use double in our calculations. Why? Because double provides us with more precision. Double provides us with more precision. If you want an accurate value, you must know that scientific experiments require an accurate value. You cannot just round up. Suppose 23.456 you are getting, you cannot just round up to 24, or you cannot just round up to 23.5. We must require this accurate value. So if someone requires 7 or 8 values or 10 values after the decimal point, they must use double data type. So it is better to use double data types as it can contain 15 digits, whereas float can only contain 6 or 7 decimal digits. All right. And another notation which we use is the scientific numbers. How we can use scientific numbers? We use them with an e. attached to it. Suppose here it is written float f1 equal to 35 e3f. What does this mean? 35 e3f. Can you decode it? What does this mean? Okay, so E means power of 10. Power of 10. What? 35 E3. This means 35 into 10 to the power 3. So 35 35000. And what does this F mean? We already know about this, as we are storing into a float data type, so we are putting the F letter to at the end of the value. So 35E3 means 35 into 10 to the power 3, 35000.0, as it can only contain decimal numbers. And what will this mean? This mean 12, and at the end of it 4 zeros, point 0. So let's try it on our window. Okay, so what is the value? Float F1 equal to 35E3F. Alright, and double d1 equal to 1 to e4 d. Let's try to print those two variables. Out.println, here we will be putting f1, and here we will be putting d1. Okay, let's compile it and run it and check the output. Okay, so what is the output over here? See, 35 E3F. So what I told, E3 means 10 to the power 3, 35 into 10 to the power 3, 35 into 1000. So 35, then 3 zeros and point 0. Why point 0? Because we are storing it into a variable with float data type. It can only contain decimal numbers. So 35,000 is getting converted into 35,000.0. And what will this mean? 12 E4 means 12 into 10 to the power 4 means 12, and after that 4 zeros. 12, and after that 4 zeros. So this is clear now, I hope. This is how scientific numbers are written, with E signs or with E attached to it. What does this E mean? E means power of 10. Alright, so let's move on to the next data type. We have already covered the numbers. So numbers are generally integer and floating. Integer contains byte, short, int, and long, and the floating point types contains float and double. All right, so let's move on to boolean data type now. Boolean data type means what? Boolean data type means it can only contain two values into it. It can either contain a true value, or it can either contain a false value. Means you can think it in like this way: switch is on or switch is off. It is a 1 or it is a 0. So suppose you are asking for a permission from your parents. If your parent says yes, this will go on this side. If your parent says no, then this will go on this side. So yes, no, on, off, 1, 0, true, false, all of those means same thing. Boolean data type can only contain two values, either a true or a false. All right, so you must remember that what is the size of boolean data type. What is the size of boolean data type? The size of boolean data type is only 1 bit. Why only 1 bit? Because it can only contain two values. So let's try to print a boolean variable. Already an example is shown over here. You can go through it. Still I'm showing you over here. Let's try to create a boolean variable. Suppose I am naming it boolean yes. Boolean yes equal to true, and boolean no equal to false. System.out.println yes, and system.out.println no over here. Let's try to compile it and run it. Let's run it. All right. See, what are the values printed over here? For yes, yes is printing true, and no is printing false. No is printing false onto the screen. So you might think that why boolean data type is used, or why this true false values will be used. Later when we will move on to programming, you will see that boolean values are of great importance. Boolean data types are of great importance. Why? Because they are used in conditional testing. They are used in if else structures and conditional testings. Just a minute, let's move it. Yeah, so those are used in if else structures, switch cases, in various loops also boolean values are used. So let's give an example. Suppose your mother asks you if you get greater than 90 in your examination, and what happens, and if you scored a plus in your drawing examination, then you will get a PS5. So what does this mean? If both of the conditions are getting satisfied, then only you will get a PS5. So this is how conditions happen. This is how conditions take place in Java or Java programming. Condition means we are providing a condition over here. If both of these things happen, then this will take place as a result. So Boolean values are used in such conditional statements. Boolean values are used in such conditional statements. They are also used in loop structures. We will dive deep onto all of those later. Let's move on to the next slide as of now. Characters, we have already discussed about it deeply on the last slide or last lecture. So it can only contain one letter into it, single capital A or single capital C or small b. I've already shown, but one new thing over here is ASCII values. Now, what are ASCII values? Okay, so this is very important and this will be required throughout your life. As long as you are programming or coding in Java, you will require it. Just remember that ASCII values stands for the English characters or English letters. What? A is the first letter of our English alphabet. A is the first English alphabet, and Z is the last English alphabet. So, as we know that you can number it from 1 to 26. First is A, then is B, B is number 2, and add, C is number 3, and so on. Z is number 26. So A is the first letter, and Z is the 26th letter. In Java programming, we don't use 1, 2, 3, 4 like this. We use the number 65 to 90. We use the number 65 to 90. So 65 denotes A. Capital A denotes the number 65. B is 66. C is 67, and so on. And what? X will be 88. Z, Y will be 89, and Z will be 90. So ASCII values, if anyone asks you what is the ASCII value of capital A, the ASCII value of capital A will be 65. What is the ASCII value of capital Z? The ASCII value of capital Z will be 90. And you also need to remember the ASCII values of the small lowercase letters, small a to small z. What are the ASCII values of those? Those starts from 97 and goes up to 122. So small a is 97, small b is 98, small c is 99, so on up to small z goes to 122. All right, so we can store the ASCII values in the character variables, and why we will print them? What will be the output? Will it print 65? No. If it would have been printing 65, then it would become a int data type. But since it is a cat data type, this 65, what will happen? This 65 value, this is an ASCII value. This will be converted to the respective character. Why? Because this is a character data type. So my var1 will not contain 65 onto it. It will contain the respective character. This 65 ASCII value determines the character A. So this my var1 will be storing a in onto it. Sorry, capital A will be stored. A will be stored. So what will be the output of my var1? It will be A. Here my var2 contains 66. What will be the output? It will be B. What will be the output of my var3, which is 67? It will be C. Suppose there was a fourth variable with the value 99 stored onto it. What will be the output? What will be the output? I've already shown over here. The output will be small c. So the output will be small c in that case. All right, let's try it once. Okay. CAD CAD value 1 equal to A. This I've already shown last day. We have already tried this. Let's try something else now. CAD V2 equal to 68 and CAD V3 equal to 100. So let's try to print V1, V2, and v3. Let's compile it and run it now, and let's check what happens. See, v1 is A. So normal A is getting printed. We have already gone through this in the last lecture. I will be providing a link if you have not gone through the video yet. So V1 is containing the value A. So it is printing A. Next comes 68. So what will be the value of 68? 65 stands for capital A, 66 for capital B, 67 for capital C, then 68 for capital D. So capital D is getting printed over here. And then comes 100. So I've already told what 97 to 122 is the range for small a to small z. So 97 for small a, 98 for small b, 99 for small c, 100 for small d. So capital D and small d is getting printed. As I already mentioned, 68 is a value, but v2 cannot print the value 68. Why? Because character data type is assigned to it. If it would print 68, then int data type would have been assigned to it. But character data type means the value here, it is a unique value, which is also known as the ASCII value. This ASCII value refers to a particular character. What character? Capital D. So this v2 will be storing the value D, will be storing the character D onto it. All right, I hope it is clear now. And let's move on to the next slide, that is string. I've already shown how to print strings. String is generally many characters, a sequence of characters. String can also be understood as a sequence of characters. String are surrounded by double quotes. And one question: suppose if anyone writes, "Is this a valid string?" Yes, this is a valid string. You may think that it is only containing a one character, so this is a character. No. If it would have been a character, then this would have been denoted like this. Why? Character contains single quotes, whereas string contains double quotes. So this is a character and this is a string. All right. So just remember that string is surrounded by double quotes and it is a sequence of characters. However, a string we cannot classify it completely into primitive data types. Why? Because string is an object. String refers to an object. Now, what are object? I told you in the last class, objects and classes. These are generally concept of OOPS, object-oriented programming. We have not gone through them now, so you won't be able to understand what are objects as of now. Just remember that string refers to an object. This object has methods or functions attached to it, and we can perform several operations on string. Methods or functions. This string object contains several functions or methods which are already predefined. There are certain functions and methods which are already predefined into it and which are used to perform certain operations. So string is generally a non-primitive data type. All right. String is generally a non-primitive data type. It is also known as the special 9 type because string is very much used in Java programming. So it is also known as the special 9 type. Those are the theory portions. Just go through it once. Why it refers to an object, what are methods, what are the operations. You won't be able to understand all of those now. Just remember that we will cover them when we will discuss about OOPS. As of now, remember strings are written in double quotes. All right. So let's move on to the non-primitive data types. Non-primitive data types are called referent types because they refer to objects. In the last slide only I told string is a non-primitive data type because it refers to an object. So non-primitive data types are also called reference types. Why reference types? Because it refers to what? It refers to objects. As we have not gone through OOPS yet, so we will not discuss about non-primitive data types and arrays and all of those. What are the example of non-primitive data types? String, array, classes, interface. We will discuss about them later. But if you want examples of non-primitive data types, these are the examples. All right. So here difference is shown between primitive and non-primitive data type. This is very important. Go through it. What is the definition? How it is defined in Java? Primitive data types are predefined in Java. Int, char, boolean. These are already defined in Java. But non-primitive data types are created by the programmer. Programmer will declare an array int a. This is how array is declared. You won't be able to understand it now, but remember that non-primitive data types are created by the programmer, but primitive data types are already defined in Java, predefined. Method invocation capability means Non-primitive data types cannot call methods or functions, but primitive data types can call methods or functions. I told you in the last slide that there are several functions or methods attached to string data type. Why? Because it is non-primitive. So there are several methods which can be called by non-primitive data types, but primitive data types cannot call methods or functions. Null value possibility. Primitive data types always has a value. Even if you declare a int variable int a and you don't put a value a equal to something onto it in any of your program, what will happen? It will be assigned a value. It will be assigned a value. But non-primitive data types can be left null. Null means what? Null means nothing. Null means nothing. So null value possibility, primitive data types always has a value, but non-primitive data types can be null. Non-primitive data types can be null, whereas primitive data types cannot be null. Naming convention means how do we name them? They start with a lowercase letter and they start with a uppercase letter. Int, float, boolean, char. The first letter is always a small or lowercase letter. Whereas in non-primitive data types, the first letter is always written capital. Strings, arrays, classes, interface, those are written in capital. The first letter is always capital. So those are very easy points. You must go through it because in several exams, those are asked. What are the difference between primitive and non-primitive data types? Give their examples, can they be null or not. So this slide is very important. All right, okay, let's move on to typecasting. This is very important. In every year, direct or indirect questions are asked in ICSE from typecasting. So what is typecasting? Typecasting is when we assign a value of one primitive data type to another data type. One primitive data type to another type. What does this mean? Let's take this example. Int myint equal to 9. Double my double equal to myint. So what is happening in those two lines? Myint is a variable with int data type assigned to it and the 9 value is stored. Alright. Here what is happening? My double is another variable with double data type. And what we are storing in my double? We are storing another variable. What is the variable? My int. My int. So indirectly we are storing the value 9 onto it, isn't it? Because my int is containing the value 9, and if we are storing the value my int into the my double, then it means that the 9 value is getting stored onto my double. But you have already seen while I was doing on the practical screen that double can only contain decimal values. Double can only contain decimal values, so 9 cannot be stored. It will be converted into 9.0. So what will happen if we print system.print my int? If we print my int, then 9 is getting printed. But if we print my double, then 9.0 is getting printed. So what happened? My int is getting stored into my double. But since my int contains 9, that 9 cannot be stored within double data type. So 9 is getting converted into 9.0. This is also known as automatic casting or widening or implicit typecasting. So converting a smaller type to a larger type is known as widening or automatic typecasting or implicit casting. Which is the smaller data type and which is the larger data type over here? Int is smaller and double is larger. We've already gone through them. Int is 4 byte and double is 8 byte. Size of int is 4 byte and size of double is 8 byte. You remember or I need to show you again? Int is 4 byte and double is 8 byte. So we are storing a smaller data type to a larger data type. So this is known as widening or implicit typecasting or automatic typecasting. So if we convert from byte to short or from short to cat, int to long or long to float or double, these are known as widening. And what is narrowing? Narrowing is the reverse. Narrowing casting. The reverse of widening is narrowing. That means we will convert from a larger data type to a smaller data type. It is also known as manual typecasting. It is also known as explicit typecasting. Explicit means that is done by the programmer or that is done by the user. That is done by the programmer or that is done by the user. How? Let's check an example. Here my double is a variable with the value 9.78d. Double data type is assigned to it. Alright, no problem. Now my int is another variable with int data type assigned to it. What will happen if I try to put my double? if I try to store the value of my double onto this my int, it will throw an error. Why? Because the size of my double is more. My double is 8 byte in size, whereas my int is only 4 byte in size. So what will happen if I try to put 8 bytes into 4 bytes? It will throw an error. So if I don't write int over here, it will throw an error. And this int is needed to be written by the programmer or by the user. So programmer is writing over here. So it is also known as manual or narrowing casting. Narrowing means larger to smaller. Larger to smaller or explicit typecasting. Means if we want to convert a larger data type to a smaller data type, we will be calling it narrowing casting or manual typecasting or explicit typecasting. And if you think that will it show an error, let's try it. Let's try with the same example. All right. Okay. So let's clear it. This is what? This is multi-line comments. I've told about this in the last lecture. Please check it. Then double my double equal to 9.78 D and int my int equal to. If you think that if I put my double over here, will it throw an error or not? See, it is showing an error. Why? What error is showing? Incompatible types, possible lossy conversion from double to int. I cannot store a double value into a int value, into a int variable. Why? Because the size of double is 8 bytes. Size of double is 8 bytes. And what is the size of int? Size of int is 4 bytes. So how can I avoid this error, or how can I prevent this from happening? What can I do? I can write int to it. I can write int to it. Means my double value is getting typecasted into int data type, and then it is getting stored into the my int variable. So the value contained in my double is at first getting converted into an int, is at first getting converted into integer value, and then that is getting stored into the myint variable. Now if I try to print it, system.println, at first I am printing my double, and then I am printing system.println, I am printing my int. Let's compile it and run it. What is the output? Check. 9.78D, that is printing 9.78. You already know why it is printing 9.78, because it is a double variable. And when I am printing my int, it is only printing 9. Why? Why it is only printing 9? Where is 0.78? Because the 0.78 will no longer be contained in the my int variable, because my double is a double variable. It is a variable with double data type assigned to it. So the double value 9.78 is at first getting converted into a int value. And what is the significance of int value? Int value can only contain whole numbers. It cannot contain decimal points, or it cannot contain decimal numbers. So 0.78 won't get stored. It will only contain the whole number part. It will only contain the number part, 9. So this 9 part is getting stored onto the myint variable, and we are trying to print it. Myint is printing 9. Alright, let's check if that was the output written over here. Yes, my double will be printing 9.78 and my int will be printing 9. Is it clear now? What is the difference between widening and narrowing? This is very important concept for your examination. I'm telling you, this is very important. All right. So this is known as widening, from a smaller data type to a larger data type, and this is known as narrowing, from a larger data type to a smaller data type. Cool. Let's move on to some quizzes then. In Java, which of the following are true about variables? Which of the following are true about variables? Okay, let's try to answer them on your own. If you cannot, check the answers. All right. Variables are named locations in memory where we can store data. Yes, this is true. We discussed about them. Those are the, suppose this is a program memory, and these are the locations with some name assigned to it. Suppose this is D, this is C, this is B, and we can store some values onto it. All right. So this statement is true. Variable names can be Any sequence of uppercase and lowercase letters, underscore and numbers, but must not start with a number. This is also true. I discussed it in the variable naming convention in the last lecture. It can be uppercase letter, lowercase letter, underscore, numbers, but it cannot start with a number. You cannot declare a variable like 9 ABC or 9 variable 1. This is not done. This is also not done. But it can be A, B, capital C. Yes, this is done. In Java, all variable names are case insensitive. No. Names are case sensitive. Variable names are case sensitive. Variable names are case sensitive. How? ABC is different from ABC, or VA capital R is different from VAR. Alright, so variable names are case sensitive. Next, Java has three types of variables: local, instance, and static. I have not discussed them yet. What are local variables, what are instance variables, what are static variables? Those will again be discussed within the concept of OOPS. But as of now, remember that this is true. There are three types of variable: local, instance, and static in Java. Next, once a variable is declared to be a certain data type, it cannot hold values of other data types. This is also true. I've already marked it true. I've also shown it last class that if you declare once int a equal to 7, and then again if you try to put 7.2 onto it, then this is wrong because a is of int data type. Can it hold value of floating point type? No. And last one is what? Variable names in Java can contain space and special characters. No, it cannot contain space and special characters. This is wrong. So first two are correct, third is wrong, again fourth and fifth is correct, sixth is wrong. Java variable names cannot contain space and special characters. Okay, so let's move on to the next quiz. Also try to solve it on your own. If you can, then try to answer it in the comment section before watching the answers. In Java, how can typecasting be classified? Means what are the types of typecasting? Just now I've discussed before two slides. Automatic typecasting and manual typecasting, explicit typecasting and implicit typecasting, intuitive and reactive, active and passive. Active and passive. Have I told about these two? So I haven't told about them. This must be wrong. Intuitive and reactive. Have I told about them? No. Explicit typecasting and implicit typecasting? Yes, I have told about them. Automatic typecasting and manual typecasting? Yes, I have told about them. So, what are the names of this? Automatic typecasting means what? Can you tell me? Automatic means widening, widening. And another one is manual. Manual. Manual is what? Narrowing. I've shown just before two slides. Sorry, handwriting is not visible, I guess. Narrowing. Here I have shown widening means automatic typecasting and implicit, and narrowing means which is done manually and explicit. So narrowing you can also tell it as explicit typecasting, and automatic or widening, this is you can classify it into implicit typecasting. Alright. So how can typecasting be classified? Automatic typecasting and manual typecasting, explicit typecasting and implicit typecasting. These two are valid. Intuitive and reactive, there is no such thing as intuitive and reactive. There is no such thing as active and passive. So this is all about today's lecture. I think you need to go through these slides because from next day we will start about operators in Java. So those operators will be part of some basic program also. So as long as you are not clear with variables and data types, so I have assigned two classes to it. I have means in the first two lectures I have discussed about the variables and data types in Java. You need to be very clear about it because while we will be writing programs, you need to be clear that whether we will use an int data type or a double data type, whether how can we use a boolean value, or what will be a character and what will be a string, what are the sizes, how can we save our memory, what are typecasting, how can we convert from one data type to another. All these things is needed to be clear. Okay, so I think that's all for today's class. If you have any doubt or any problem, you can mention in the comment section, and please do like, share and subscribe this video. A lot of effort is required to make those videos, and I am doing all of this for free, all of this for you, and that too free of cost. So yeah, just put a like and share those with your friends. Thank you.